Here's a fast way to get a common denominator that is the least common denominator between two denominators that have common factors. A lot of times these will be larger numbers. So the first thing you do is you find the prime factorization of each, and you can do that in your head. 15 equals 3 times 5. That's the prime factorization of 15. 24 is 8 times 3, and we know that 8 is 2 cubed. So 24 is 2 times 2 times 2 times 3, or you can think of it as 6 times 4 broken down. So now that we have the prime factorization for each of these denominators, we are going to look and see if there are any factors in common. And we notice that they have 3 in common. Now, I don't want to worry about those 3s. They have that in common. My goal here is to have the same prime numbers to make up our least common denominator, because prime numbers can only equal one thing when multiplied together if you have the same prime numbers. So here, I'm going to look and see what 24 has as prime numbers that 15 doesn't. It has 3 2s. So I'm going to multiply my denominator by 3 2s. That way I've included every prime factor of 24, the 3 and the 3 2s. Now I know that 2 times 2 is 4, 4 times 2 is 8, so I know this equals 8. So I can multiply the numerator by 8 or by 2 by 2 by 2. It doesn't matter how you write it, but it's the same value. We're multiplying the denominator and numerator by 8. Now I'm going to look at the 24, and I have 3 2s and 1 3. My 15 has 3 2s and 1 3, but it also has a 5. So I need to multiply the denominator by 5 in order to have the same prime numbers that I have for my first fraction. If I multiply the denominator by 5, I have to multiply the numerator by 5 as well. So now you'll notice that I have the same prime numbers for both denominators. I have 3 2s, a 3, and a 5. What that means is when we multiply those numbers together, we should get the same number, and that will give us equivalent fractions since we multiplied the numerator by whatever we needed to multiply the denominator by. So in our numerator, we're going to multiply 14 by 8, which is 112. And then we're going to multiply 15 times the 8, the 2 times 2 times 2 in the denominator, and 15 times 8 is 120. For our next fraction, to get equivalent fractions, we're multiplying 21 times 5, which is 105 in the numerator. And then in the denominator, we're multiplying 24 times 5, which gives us 120. We should get the same denominator for both of our fractions if we did everything correctly. Now that we have common denominators, we can add the numerators and keep the denominator. So we get 217 over 120. Of course, we will simplify this. 120 goes into 217 one time, and then 217 minus 120 is 97. So we have 97 left over. And that's our answer. Let's look at another example. On the next page here, I have 1/18 plus 1/15. We're going to find the prime factorization for each denominator, and this only works when they have common factors. So can you think of a common factor of 18 and 15? If you thought of 3, you're correct. So 18 is the same as 3 times 6 or 9 times 2. So I'm going to do 3 times 3, which is 9, times 2, 18. That's my prime factorization for 18. For 15, I have 3 times 5. So let's think about what we have in common. Both numbers have a 3 in common. That's a common factor of 18 and 15. So they don't have anything else in common. So I'm going to multiply by whatever I need to multiply by so that they have the same common factors for the denominators. So if I look in the 15, I need to have a 5 for my 18 as a denominator. So I'm going to multiply by 5 in my denominator. So now I have the 3 and the 5 that I see for the 15. Since I multiply the denominator by 5, I multiply the numerator by 5 as well in order to have equivalent fractions. Now for my 15, I am missing the other 3 and the 2 that the 18 has. 18 has 2 3s, so I need another 3 for my 15. And it also has a 2, so I need that 2. Well, 3 times 2 is 6. I'm going to multiply my numerator by 6, or by 3 times 2, same thing, in order to continue having an equivalent fraction. So now I'm going to get my equivalent fractions. 1 times 5 is 5. 18 times 5 is 90. And my other fraction, 1 times 6 is 6. 15 times 6 should also be 90, but I always want to double check to make sure that I did this correctly. So I know if I get the same denominator for each, I'm probably on the right track. Now I can add my numerators and keep my denominator, so my answer is 11/90.